Okay, so if we say the word compound, we're saying that it has a definition of together. We okay with that? Okay, compound is like when things are sort of combined together. Okay, so we're going to have two inequalities now combined together. Okay, so that's the compound piece. Now, this word or does not mean like I'm missing another option here. Compound OR is the type of compound inequality we are going to look at. So this is an even trickier one. What does the word OR mean in the English language?
I don't know, something other, like two choices.
Oh, I love that word, right? You have two choices, right? You have choices to pick, okay? And what does then OR mean with that choice? So if your parents send you to the store and say you can buy a shirt or pants, how many things are you buying? One, right? You can pick one, right? So compound means together, so we're going to have two inequalities. Okay, and the word OR is telling us that we can sort of pick one. Right? It's like a choice. Do you want this one or do you want this one? You can do either. Either of them are fine. Right? You could get a shirt or you could get pants. They're both correct options. Okay, but you're picking from one of them. Does that make sense? So here's what it looks like. X is greater than or equal to 7, or X is less than 2.
So go by which one is true?
They're both true.
Oh.
Okay, it's telling us that they're both true. So if they're both true, okay, we have the option that we can just decide, I can't remember, I think it's Brayden who I picked on before. Brayden, your homework assignment is to go home and write down all of the numbers that make this true. Okay, so who can give me a number that makes this true? Let's think about what would work for this. Okay, so if I pick -4, is -4 greater than or equal to 7? No. Or is it less than 2? Yes. So does it make one of these true? So is it a potential answer? Yeah. Who can give me another answer? 8. Is 8 greater than or equal to 7? Yep. So does it make one of these true? Yep. Who can give me another answer?
5.
Is 5 greater than or equal to 7? No. Is 5 less than 2? No. So does 5 make one of these true? No. So is 5 an answer? No.
Could it one be 7 because it's greater than 2?
7 could be an answer because it's or equal to. How about 10?
Yeah, that's one.
Is 10 greater than or equal to 7?
Yes.
How about 11? How about 12?
Yeah.
How about 12.1?
Yeah.
How about 12.11? How about 12.111? How about 12.1111? How about 1.9? 1.99? 1.999? Because that's less than 2?
Oh, yeah.
1.99999. Right. How long would Brayden be doing his homework if he was going to write them all down? For forever, right? Because this has an infinite amount of numbers. Now, is it all numbers? No, because we found an example like 5 that doesn't work. So it's not all numbers, but it is an infinite amount of numbers. So our solution, when we couldn't write them all down, was to do what? What did we do with like x is greater than 2 when we couldn't write down all the answers? How did we represent all of the answers? With what? You just did it on your quiz.
Solving? What was the question?
If we can't write down all of the numbers that are greater than 2, we would graph it to represent them all. So that's the same approach that we want to take with compound inequalities. Okay, if we can't write down all the answers, let's give a representation of all of the answers. Does that seem fair? Okay, so let's make a number line. Except now we need some different numbers on our number line. What numbers do we need on our number line now? Yeah, we're going to need 2 and 7. So here's the catch. My students are like, well, do I need to put all the numbers in between? Well, no, because if we have negative 42 and 571, listing all the numbers in between is going to be a big pain in the rear. Okay, so you only have to have 2 numbers on your number line, and the 2 numbers you have to have are the 2 numbers that are given, but you have to have them in the right order. So which one of these is going to go on the left?
2.
Because 2 is smaller than 7. How you doing with me so far? So far, so good? Okay, now, when we graph, no new graphing rules. We just have a new graphing step to interpret with. So we are going to look at one of these equations. Okay, so I'm going to look at x is greater than or equal to 7. If I were to graph that, would that be an open circle or a filled in circle? Filled in, except now I'm not going to graph on the number line. I'm going to graph above the number line. So remember how I told you it was really important that we were graphing on the number line? Because there'd be some other stuff going on. For now, we are going to graph above the number line. It'll make sense here a little bit, so just bear with me. Okay, so filled in circle. Am I shading to the right or am I shading to the left? To the right. Open or filled in circle at 2. Open to the right or to the left? Well, we're just using this to sort of interpret. So yes, those technically have arrows on it, but we're just using this to interpret right now. Okay, now we said the word or meant either of the situations, right? Just one of them needed to be true to be good. So we want to copy down onto our final number line anywhere that at least one of them is happening. So our final number line is going to have anywhere at least one is happening. Because we said the definition of or was that we only needed one of them to happen. Okay. So think about this a little bit like Tetris. Am I too old for Tetris these days? Do you guys know what Tetris is? Right? If these 2 things were to fall down onto the number line, where would the number line get touched? Okay, so do we agree that this would fall down and touch the number line right here? And so I'm going to copy this onto my number line. And do we agree that this would fall down and touch the number line over here? And at this point, my students are like, Mrs. McKinney, why did you make me graph that above? That's the stupidest thing I've ever done. Like, oh my gosh, that's busy work. Okay, I promise it's going to make sense between today and tomorrow. It's really important that you graph above and then you interpret. Okay, so this says you can pick any number over here on the number line, and you can pick any number over here on the number line, but we can't pick anything between 2 and 7. Okay, we can pick 7, we can't pick 2. Right? Does that make sense? Questions on that? So far, so good?
So do we need to put down another number?
No. You can just have those 2. Okay. Let's look at another one. And it's okay if right now you're kind of like, I don't know where this is going. This seems really weird. Just kind of go with me on it for a minute. How about x is greater than or equal to 4, or x is greater than 2? two inequalities, right? We have the word or, so this is picking one. So we're going to go down here to our number line. We're going to make a number line. What number is going over here?
2.
What number is going over here? Okay, and we're going to graph them both separately up above. So open or filled in circle at 4?
Filled.
Filled. And then we're going to shade this to the right. Open or filled in circle at 2?
Open.
Open. Let me get a different color. To the right or to the left?
Right.
Right. Where are we at so far? Are we doing okay? Thumbs up, thumbs down? We're with me? Okay. So we want to bring down onto the number line anywhere that gets touched at least once. So does this little area over here get touched? No. Does this area get touched? Yes. Does this area? Yes. So our final answer of what we're bringing down onto the number line is this.
How do we get our final answer?
Because the
Okay, so what I'm doing is, do you know what Tetris is, Kaylee? Okay, okay, so imagine this being like it's floating and it's dropping down. Do you understand that idea that I'm saying with that?
Yeah.
Okay, so if it's falling down, where is it going to hit the ground? And any place that the ground gets touched is part of our final answer. Okay, so there's nothing over here to touch the ground. Okay, the ground gets touched right here because the blue will touch it. The ground gets touched right here because the blue and red will touch it. So any place that gets touched becomes part of our final answer. Okay, now, how come I didn't put a filled in circle here? Do I need a filled in circle there?
No, we don't link to.
No, right? Because this shading takes care of it for us and says that we're including that value. Okay, and so what this tells us is that instead of writing this as a compound inequality, we could just write this as x is greater than 2, which would be way easier. Yes, Leah?
will it always be an open circle?
Nope. Nope. That was a good question. That was just a coincidence.
How do we know when we graph one is on the other example?
So on this example, right, if these fall, where does the ground get touched?
Oh, I think so.
Right? It gets touched in two separate places. That's why we're graphing above, because it just depends on the problem. And it gets more complicated tomorrow when we have a different version of the compound inequality. So we always want to graph above so we know what we're interpreting below. Okay, yes?
So how do you choose which one is correct, you could say? Because aren't you choosing one of them and you're graphing them to choose?
Okay, I think you're making a wrong statement about being correct. Either of them are correct. They are both correct. Okay, if you go to the store and your parents say, okay, you have $20, you can buy a shirt or pants. You can buy a shirt or a pair of pants. If you come home with a shirt, are you okay? Are you right? If you come home with a pair of pants, are you right? If you come home with a pair of shoes, are you right?
No.
No, so this area is sort of like where you bought shoes, right? Here's your shirts, here's your pants, okay? Here, this is the area you had to buy shirts. This area you got to pick shirts or pants. Over here is where you're buying shoes.
So both of them are still correct?
Yep, so all of this falls in one thing as being correct.
So is that just an answer?
Yep,
So they're both correct. If you pick something other than shirt and pants, then it would be right.
correct. Shirts is correct, pants is correct. Just like when we were solving absolute value equations, x could be 2 or x could be 3, right? There's 2 correct answers. We have 2 correct answers. It's just that an answer is a lot of answers in inequalities, which makes it even harder to wrap our brains around. Okay. So what happens if we have this? X is greater than -5, or x is less than or equal to 0. Things are not super great today, sorry. What number am I putting here? -5, right? Because it doesn't matter which number is first or second up here, right? We're going by which number is smaller. The smaller number is on the left. Which number am I putting over here?
0.
Okay. Open or filled in circle at -5. To the right or to the left?
Right.
Open or filled in circle at 0. Filled in to the right or to the left? Okay, so now we're going to bring down the number line anywhere that would get touched.
Wait,
Right? Does it get touched over here? Sure does. Does it get touched here? Sure does. Does it get touched here? Sure does. So, right, the whole thing gets touched. How do we think we would write down an answer if every single number gets included? I'm going to go with something that's more of a number line things. All solutions is fine. We didn't really solve anything, but all solutions is fine. All real numbers, right? It's the entire number line. We're including all real numbers. How do we feel about that? So, guys, that's the trickiest piece of today. Okay, if we can figure out those graphs, that's the trickiest piece, because compound inequalities graciously make it super easy to solve. Sorry, I'm just letting people finish writing it up and check the page and leave people behind. We okay if I flip? I don't leave anyone behind. To solve a compound inequality,
Teachers, at this time, all sophomores with the last name beginning in K through N, please report to the LGI for hearing screening.
Right next to 0.
the LGI.
By the bathroom.
The LGI is down over by the auditorium.
Alright, I know.
Yep. Okay, solving compound inequalities is super easy with compound OR because it's just one or the other. It basically says solve two separate inequalities. So it's kind of like doing two problems instead of doing one. And since we all just did awesome on our solving inequalities quiz, this should be no problem. Okay, so how do we solve x plus 8 is greater than or equal to 10? How do we solve this one?
Divide by -8, you have to switch signs.
Right, we're dividing by a negative, so we're gonna flip the sign. We could then graph it if we wanted to graph the answer, right? But there is no extra added rules because compound inequalities are just two separate ones, okay?